Now let's come to the question number 2, which talks about uniform acceleration and deceleration. Okay, the question says a cam is to operate a flat-faced follower with uniform acceleration and deceleration during ascent and descent. The least radius of the cam is 50 millimeters. During descent, the deceleration period is half the acceleration period. The ascent lift is 37.5 mm. The ascent is for 1/4 period, dwell for the 1/4 period, descent for 1/3, and dwell for the remaining 1/6 period. The cam rotates at 600 rpm. Find Vmax and Amax during ascent and descent. Okay. So first of all, let's find out the acceleration period during the descent. Okay, the descent is for 1/3 of the entire cycle. So you go 1/3 into 360, and it is double the deceleration period during the descent. So you will go 2/3 more. So it becomes 80 degrees. This means the deceleration period during descent this is half the acceleration period during descent. Okay, this line. So this becomes 40 degrees. Okay, the ascent lift is 37.5 mm into 10 to the power minus 3 meters. Okay, let's find out the distance moved during the acceleration. Okay, in the descent period. So you will have 80 by 120. That's the total period of descent into 37.5. This gives you 25 millimeters. Okay, the distance moved during deceleration. This is again during descent, so it will be the half of this, 12.5 millimeters. Now theta 1 is ascent, 1/4 means pi/2. So Vmax, okay, Vmax during the ascent, this would be 2 omega h upon theta 1. Now what is omega? The rotation is how much? It is rotating at how much? Is it given? Yeah, it is at 600 rpm. So omega 2 pi into 600 by 60. So you get 25 radians per second. Okay, so this h is this, and theta 1 is pi/2. So you put the values in this. So 2 into 20 pi into 37.5 into this upon pi/2. So this gives you the Vmax. Now the Vmax during the descent would be how much? Vmax during descent, it is 2 into h upon t. Now time period during the descent is 80 into pi. So you get 2 into h upon 80 pi. So this gives you the Vmax during deceleration, and this is Vmax during ascent, and this is the Vmax during the descent. Now we need to find out the maximum accelerations. Now after Vmax, we need to calculate the Amax. Okay. So Amax during ascent. Amax during ascent. This is 4 omega square h upon theta 1. Theta 1 is pi/2. So you get 4 into 20 pi whole square into 37.5 into 10 to the power minus 3 upon pi/2. So this value would be 240 meters per second square. Similarly, if you just want to find out the Amax during descent, this would be Vmax by T. And this is 3.375 into 360 into 600, that's the RPM, by 80 into 60. This gives you a value of 151.875 meters per second square. So this is the acceleration values and these are the velocity values. Okay, so make a note of this, and after this we'll move on to the third question on the topic of cams.